T-minus 10, 9, 8,
The clock is
7.
operating. We're underway.
Tranquility Base here.
Endeavor, go.
See, before we've been seeing this and saying this is crappy, and that's the spot that they're heading. Right. To me, see the boulder? It's got a dark side there. Do something up there, but then if you come around,
This is 120 meters away.
yeah, bad until you come around, and then here's a ledge in the middle. This could be the outcrop that's Kaibab.
Is what wasn't transferred correct, so.
That's what I was just told.
I think that was not correct.
From Ashton.
We can either drive straight to there, or we could do what we're now calling a go look go, which is to come by. This is clearly a nice cross section through the soil or the gravels. There might be some useful information
just drive to here.
there. Yeah, drive, do a quick pan cam, and then could we still get there in a day?
All in one song.
All in one song.
Yeah. Okay.
All the data that accompanies that signal. So if something fails during transmission,
Right.
we're going to find out here.
Yeah. Okay.
So that's
Is if we get in there and we find out on the basis of UHF data that we can do remote sensing, but we can't do IDD, then I'll try to get the full set. Whereas if we're going to do the drive, I'll get a very compressed set of just the highest priority stuff.
This one, that one there.
Is that big?
We could do a raster scan.
Okay, so it's two big outcrops.
That's 97.
One there,
This is 82
one there.
meters.
Again, into an intermediate spot here and then try to come out this way.
It's fine.
What hour?
115.
Yeah.
13:15?
Okay, so
Yeah, we're okay.
seems to me we still got two.
We can,
Okay, Deborah. We got two mini test targets.
okay,
Number one is Kaibab.
okay,
Number two is Hawk's Nest.
thank you.
Okay?
We don't know if people were there.
Okay, so no additional information since the science assessment meeting.
Exactly.
Okay, thank you. Before we go.
This is only necessary if the arm didn't work yesterday.
Well, it could be the right thing to do anyway. If we need more time, we can delay it, but that's what I'm going to shoot for. SOWG meeting goes from 13:15 to 1400.
But anyway, keep coming around. So here's our ledge. And you got ledge up here and a ledge down here.
It comes down to C right here,
Yeah.
which is neat.
But what we had to do instead was 15 degrees, 30 degrees, and 45.
Put in our unit, you can relate that to where it came from.
Well, hopefully.
We can address by driving towards the left side of the valley. The other issue is that
Sorry,
if we,
which direction is that? What's the rough heading?
so that's roughly
310.
320.
T-minus 10, 9, 8,
The clock is
7.
operating. We're underway.
Tranquility Base here.
Endeavor, go.
I mean, they're gonna see there's no
So how much more of the pan do they have to do?
I think this is the last swath.
Oh, really?
They do vertical swaths. And they'll stow the mast. When you see the mast start stowing, then after it's done, it will drive 5 meters forward. So it'll probably end up right by that.
Just make sure they're going to do what we want them to.
On that corner and lay it there.
On the mast and ready to start running. Unless these guys have something different to say, I think we're ready to go. Over.
John?
Over a cliff or something.
Yeah, we had a lot of trouble with licensing of that.
I heard. Got it. Over. Okay, we need to pick up, guys. Where's the first shot? Terry, which direction is the first shot on that 360 pan? Over.
I think it's right at you.
And so as I was looking around like this, it was hidden behind my sleeve. And I found the radio, I got on, I said, pause the sequence, truck coming. And I said,
T-minus 10, 9, 8,
The clock is operating. We're underway.
Tranquility Base here.
Endeavor, go.
The point of this test is to train the science team in how to do field geology with a robot that is somewhere else. Okay, remote field geology with a robot. That's not an intuitive thing. That's not something that comes naturally to a field geologist. I've got some of the world's best field geologists on my team, but they are used to being able to go someplace where they've got a rock hammer in their hand and they got boots on their feet and they've got a hand lens for looking at the rocks and they can interact with the terrain and touch it themselves and walk around and look around. And that's very, very different. It's really very different from trying to do field geology through the eyes of a remote robot. And so teaching the team how to do that is really what this test is all about, and we don't have to have an exact duplicate of a Mir rover to have that experience. There's an enormous support staff here. We've got 50, 60 scientists flying in from all over the world to participate. This is a big deal. This test takes a lot of time, a lot of effort, a lot of money. We got to stay real focused on the task at hand, which is doing the best job that we can for 10 days of really simulating the science that we're going to do on Mars. That's what we got to stay focused on.
T-minus 10, 9, 8,
The clock is operating. We're underway.
Tranquility Base here.
Endeavor, go.
The primary objective of this field test using FIDO is to train the science team in how to do field geology with a rover. The FIDO rover is very similar to the MER rover. It's not identical, and not all the processes are the same, but the ones that involve science decision-making and planning are very similar. So this is an excellent exercise to bring together our full science team and really train them in how to be able to operate the eventual MER rovers for operation on Mars. This is what's called a blind test, in that we have the rover placed in some undisclosed location. So the science team back here at JPL, all they know about the site is what the rover tells them. So they're seeing the site only through the eyes and ears of the FIDO rover. And that's exactly how it will be on Mars. We won't know exactly where we land on Mars, and so we'll only know what the rovers tell us.